This is the Hamann Automatic 500, and I figured I'd just go over a little bit of how the multiplication mechanism works on this, because it's kind of interesting and really more interesting than I thought it would be. Division on these machines is pretty much dead simple, but multiplication is a bit more complicated than that. So I figured I'd take a little bit of a look through that. So go on to the back where the multiplication mechanism actually is. See, I got my little vice grip crank on here, so I can turn it over by hand before putting the motor back on. Easier to demonstrate that way. So down here in the bottom, which you won't be able to see it very well, but inside this little hole here, you can kind of just barely see a spring all the way down in there. And that big spring there advances a pegboard similar to any 10-key adding machine. You can call it a pinboard, pegboard, whatever you want to call it. Let me see if I can enter some numbers here. So you'll watch as I enter numbers, this rack here will advance along with this gear train. This gear has a shaft that goes all the way down to the tooth rack right here, and this tooth rack is on the back of that pegboard. So as I enter some numbers, you can watch that advance. See that tooth rack has now advanced into there, and you can now see the pegboard there. See those pins there, if it will focus. So you can just see those two pins there are some of the pins, and they got little spring detents on them to hold them in place, whether they're pushed up or pushed down. When they're pushed down, they're non-active. When they're pushed up, they are active. So you can kind of see them sticking out of the bottom there. Those are the non-active ones. You can't see the top. The top is where the active ones are, so they pop out the top, and then they're sensed by fingers, which is what this conglomeration is here. This piece here, this shaft with all the funny discs on it is, you can't see it very well, but that's the multiplication mechanism. So I can balance this here somewhere. It's not great, but see that each of these discs move and they're detented. And this is the multiplication register. We'll come to that in a moment. But underneath these springs here is another shaft that has rockers on it, which you can kind of see the back side of the rockers here, those little nuts with the pins on them. Those are attached to the rockers that sense the pins on the pinboard. So let me clear this out. You can do that manually. Normally you wouldn't do that manually. The machine is automatic, but so let's enter something like 1, 2, 3, 4. So you'll see it's spaced out to position 4. Now, if I push this 1X button, this will transfer what's entered on the pinboard into register 1, which is this register up here. So I push this, it disengages this clutch right here. And then what happens is you'll see, as I turn see if I put a light there maybe. Balance this here. Yeah, this is not going to work out that well. Kind of need more than 2 hands for this, but there. Now you can see it. So as I turn this, you'll watch. See how they pop forward? And they'll advance down. And there, and as they're advancing, the register is moving. So those are swinging, basically rocking on the shaft there. They swing down. There's 2 segments on the top here, which engage with intermediate gears under here, which then drive the actual register gears. And you'll see then it gets to the end, it resets the pegboard automatically. And that's how it enters a number. So, yeah, again, it's kind of hard to show. These springs here are what lock the segments in position. So if you look down in here now, you'll see that, back over to this side, all of the secondary segments are against the shaft, whereas on this side they're not. They stay out relative to what's entered in on the register. So these pins, nuts here with the little pegs on them, are actually what drive that, which you can kind of see there if you would focus. So those little nuts with the pegs on them are actually attached to the rocking segments that sense the pegboard, and then they drive rocking segments on the same shaft. And there was secondary rocking segments that would actually drive the register, and the secondary ones stay engaged. I get some better light on this, but it's not going to work very well. The secondary segment is staying in position relative to shift in the register, and then when you clear it out, or when you enter a new number, it first resets those and then drives them to the next number. So if I enter another number here, let's say, just enter something, do 1x. So now if you watch, if I can get in here maybe, get a good view. So if you watch down in there, they reset, so they see how they came back. You can see that, not very well. But now all of the, see now they're all back against that shaft. So they've all reset, the register is back at 0. And now it's ready for the next sense, so it'll drive them forward again, relative again to what I just entered on the pegboard, and then resets the pegboard. So that part is critical to understanding how multiplication works, because what will happen when I do multiplication is it will transfer the result that's currently in this register 1 up here back to this multiplication register down here. So you can just back onto the front. So let's enter a number for multiplication, say 625, and now when I push 1x, it will transfer that up to register 1. See if we can get a full thing in view here. So it's transferred my 625 up to register 1. So now I pick another number, say 625. Now when I push this equals button here, the first thing that will happen is this multiplication register will spring forward. Let's see if we can see that. So I'll push multiplication now, or equals rather. See how it sprung forward? So now what that's done is that sprung forward to engage with two segments on the same rocking segments that drive the register 1. So you can actually see it sticking up there. That little pin is the back of the tooth segment. You can actually see some of the teeth on it in between those springs there. Kind of tell that's a tooth there. So that's the one that's set to 6, so that's the furthest up. This one's only set to 2, so it didn't come up very far. This is the one that's set to 5, so you can kind of see maybe 1 or 2 teeth poking through there. So now those have engaged with this multiplication register, which you can see down in there. So now, if I can get this light in a decent place to turn the crank handle, if you watch down in there as I continue, it will see how it transfers back the clearing action of register 1, which we showed before, is now happening. It's resetting register 1 to 0. As it does that, it's driving the multiplication register to contain the contents of what was in register 1. And now what's going to happen is it's going to continue with a regular load of register 1 to the number that I've now set most recently on the pegboard, which again happens to be 625. But right now that first 625 has been transferred from register 1 into the multiplication register. Now that that's done, it's going to load the pegboard, which again is 625, the second 625, into register 1. And after that happens, then this mechanism over here will engage. Let me just go to this flashlight. So continue. So it's now loading 625 into register 1. Now that's engaged, so this is the actual multiplication clutch. What's going to happen is it's going to, this is going to come around half a turn, and then this finger is going to engage the same clutch and keep this shaft half a turn out of its normal resting position. And as that happens, it's going to release a finger, which again, you're not really going to be able to see. It's all the way down in there. I haven't even been able to see it myself working on this machine. But what you can see possibly is over here somewhere, right there, that black thing in the middle there is a tooth segment. So if you watched how Freedom does multiplication, this is kind of similar to that, where it has a segment that kind of, rotates like this, and then for every cycle of the machine, it advances it by 1 place until it gets back to 0. What's going to happen is, let's see if I can get a better view of this, but that's going to swing it down. There, you can see the teeth on it from down there. That's going to see how it swings down. So that's swinging into the gap on this multiplication register. So down on the bottom of this, there's a finger that comes in into the gaps there, and that's why these teeth have all these different length gaps on them. So depending on which position the wheel is, determines which depth of gap aligns with that finger, and also controls the shortcut multiplication. There must be a secondary finger down there. Again, I can't see it myself, so I can't explain it that well, but there must be a secondary finger also that senses the depth of the gap to know whether it is a shortcut or a non-shortcut, and then that will, through this piece over here, so that piece with the T on the bottom and the funny long gap there that my finger is on, so that piece determines whether it's subtraction or addition for the shortcut multiplication. That will swing either all the way back or partially back. When it's partially back, then that engages this piece here, which will swing a little bit in. You can see the gap on the guide there. That can swing in for subtraction or out right now for addition for the shortcut multiplication. So right now what's going to happen is the machine will start adding, and as it adds for every cycle, see, it advances it by one position, and up here you can see that this wheel has locked into that back clutch. Now we'll continue through here. It's going to go up 5 times. Now it's reached 0. You'll see that this clutch will disengage. Wheel will continue forward. You can kind of see the register is it's finished shifting. So now it's going to do the 2. So let me get back into position here. That's 1, that's 2. So now it's at 0. The clutch is disengaging. The register is shifting. Right there, it shifted. I come back around, and now it's going to be a shortcut. So as you can see, this piece here has shifted over for subtraction. Now it's going to, instead of adding 6 times, it's going to subtract 4 times and then do another shift and another add. So yeah, I don't think I have that much more to show from the back. We can probably come back around to the front and you can watch it happen from the front. So it subtracts 1, 2, 4 times, does an add, and that's it. So you can see that last 6 there, instead of adding 6 times as a shortcut, it subtracts 4 times, shifts over, does an add, so you basically save you know, a cycle there. It's an efficiency. Now you can see you've got 625 times 625 is 3965, which is the correct answer. If we come over here, just if you're curious, so this piece right here, this is what advances that every cycle. It advances the ratcheting segment down in here. This is attached to a cam here, which for every cycle of the it's not a pinwheel cylinder, but the ratcheting mechanism drive shaft, this rocks back and forth for every cycle of that, and then this rod here, of course, swings back and forth, which is what is attached to that finger you saw advancing the tooth to rack up 1 position for every cycle. So yeah, as you can see, this multiplication register still has the result. In order to clear that out, we need to do a register 1 clear or a register 1 enter. So we can just hit register 1. So register 1 is loaded. Now if we come back around here, you'll see that the multiplication register has now been reset. It is all back to where it should be. You notice that some of these don't quite, you know, there's a little bit of looseness here. I'm not sure if you can see that, but like I'm wiggling this wheel, so this can be in any number of positions, which I'm not sure if that's a problem. Now I was first playing around with this, I was having a real hard time getting multiplication to work properly. And what I eventually found out, what was happening was, you'd enter a number, say 625, and it would, when you would multiply, instead of doing 625, it would do like, you know, 685 or something. And what I found out what was happening was this multiplication register, these wheels, were not being set to the appropriate position. And at first I thought it was an issue with the detents, they were not locking in, so I was playing around with trying to bend some of the detents to make them more stiff and locking the wheels in, you know, a more firm position. but that didn't really help. And what I ended up figuring out was that up here, these little nuts with the pins on them, those pins actually lock in to the backs of the secondary segments. So, you know, when the register load happens and those fingers start swinging forward to sense the pegboard, those little nuts on there actually lock into the secondary segments, and they don't just push them, they actually lock onto them. And what was happening was those, they actually pivot a little bit. They're on like a little triangular piece. And when the register load happens and the primary segments swing forward, those are supposed to drop down. Yeah, I don't think you'll really be able to see it. But there's actually hooks, kind of cutouts in the back of the secondary. Yeah, you can kind of see how that second pin there is almost, you know, kind of see how it's almost like in a gap in the secondary segment. So when it swings forward, it actually locks into that gap and prevents the secondary segment from overshooting and basically locks into the primary segment. What's happening was those triangular segments with the nuts with the pins on them, they were frozen and they were not locking in, and the segments were kind of, you know, just free floating. I mean, they were being pushed by those pins, but not actually being locked to them. They were kind of free floating, and that was kind of, you know, giving too much momentum to the multiplication discs back here, and these were kind of, you know, way overshooting where they should be, and that's what seemed to be causing the issue. Now, again, I'm not sure if the weak detents of some of these is going to be an issue going forward, but so far it seems that since freeing up those pieces, my multiplications have gotten, you know, pretty accurate and seem to be working okay. So hopefully that's the only issue. A word of caution, if you do have this issue and you do free those up, those triangular pieces with the pin nuts on them, they can actually over center out of the primary segment, because the primary segment has just a tooth fork on it, and then the piece of metal there you can see with the pin nut going through it is like a triangular piece. So on this corner of the triangle it has that pin nut. On the top corner, which you can't see, it's under there, is a pivot, and then on the back corner there's just a pin there, and that pin goes into a fork on the primary segment. The primary segment is spring-loaded, so if you pull too hard on this side, it'll actually cam out of the primary segment, and then you have to get down inside there with picking everything and try to pull the primary segment back far enough that you can kind of like over center it and get that pin back in the fork. And it's not a fun process, so just be careful of that. So yeah, I guess I can probably do one more demonstration from the front side just so you can see the whole complete operation here. So let's see, we'll clear out registers 2 and 3. We'll do 625, register 1, do 625 equals. Now as a shortcut, so it subtracts 4 times and then adds back once. And there we go, 625 times 625 is 365. So kind of just want to give a little overview of that. You know, I haven't seen any real detailed information as to how that works. I mean, this is obviously not a complete explanation because, you know, there are parts that, you know, even I can't see buried down deep in the machine, but I just want to give a little overview of, you know, the primary steps and the primary actions of how multiplication works on these. Yeah, so hope you enjoyed this video, and thank you for watching.